start with a good review of 2A. And so we did do just a smidge of rounding before that, but in 2A we moved on and we focused on unit analysis. And so this is just a fancy way of saying we're going to use the units that are in the problem to help us instead of just totally ignoring them like we used to sometimes, I feel like, when I was in middle school. So that's led us to several good definitions. One of the first keywords and definitions that I can think of is per. And so per is a way to mean for every. And so for every often implies division. And so you need to be careful, this doesn't necessarily mean we will divide. Every once in a while we do other things, but it does imply division. So for instance, if we were trying to find the unit price, what we've learned in this unit is this is the price per unit. So if I need to find unit price, I can take the price that we're paying, like $6, and divide it by the unit. Say I was getting 1.5 pounds of beef, and then I would have the price per 1 pound, a unit price. If I had the unit price, thinking of an example from your test review, it says if hardwood flooring costs around $15.60 per square foot, so $15.60 is divided by square feet there technically, how much would it cost to cover 330 square foot living room? And so here I've got per square foot, so I'm dividing by square feet. Then if I will multiply by the total number of square feet, you know, that cost per unit times the total number of units I need, I'll get my total cost to answer that question number 2 there. Number 3 is a great example of another place we see per, and that's an hourly wage. And so we need to remember hourly wage is the number of dollars that is made per every 1 hour, right? It's a unit price, kind of like hourly wage, but in what we get paid instead of what we are paying. And so for number 3, it says if you earn $368 for 48 hours of work, I can take the dollars, divide it by the hour, and get the hourly wage here. And another one in there that we see per in a lot is just speeds. If you'll remember, speed is a distance per time. And so we commonly see miles per hour, mph, and that's miles divided by hour. So if I drove 4 miles in half an hour, I can divide those two. That's 8 miles per hour. We also did some conversions with those. Also in unit analysis, we saw the value of, and we learned that it does imply multiplication. Now, if you're thinking ahead to 3A, where we saw of a lot with percents, you may be thinking, I divided to find percent of. And I want you to remember back to like way on back when you were solving for things. Sometimes we do the inverses or the opposites to solve. And so if I were solving for percent of, I would probably use some division there. But if I have the percent of, then that can be multiplied by what it's the percent of. If I have those two numbers, there I do use multiplication. We also worked in the world of areas and volumes, and so it's good for us to remember in this interesting word we learned that squares and cubic, and so these are both a special type of exponent. Square is the second power, so it looks like feet squared, for instance. Cubed is the third power, and so, you know, sticking with the same example, that would be feet cubed. Squared is the appropriate exponent on a unit of area, whereas cubic is the appropriate exponent on a unit for volume. And so sometimes it helps us, right? If area is supposed to be squared, what I need to do is to take one unit and multiply it by another unit. If those two things accurately represent like the space I'm trying to find the area of, and then in volume, it may be that we take that area and we multiply it by the height or the whole, you know, we have some longer volume formulas used a little bit. Either way, this way we end up with that unit cubed. It's a good sign for volume or for filling up the space. And here we end up with units squared. Another big part of this section was something not everybody loves, which is conversions. And so sometimes your conversion problems will be like, hey, convert this. to this, or sometimes they don't. They just kind of mention, you know, like, here's a starting unit, let's get to a different unit. And so whether they say, let's do it this way, or you're just realizing you need a different unit as you go along, we work it similarly. So we're going to start the problem with what we have been given. So the given value in units, we're going to multiply by one fraction, or sometimes two, or sometimes three, that we use conversion factors for, and this must equal 1. So for instance, I could put 12 inches over 1 foot, those are both the same, or 1 foot over 12 inches, those are both the same, but I can't put 12 feet and 1 inch in those fractions because those are very different. And you continue this multiplication process until you arrive at a new value and the requested, that's an abbreviation for requested units of where we're going to stop. Generally, I get a few questions about exchange rate problems, which is a type of conversion problem. So you're going to start with what you were given and multiply it by a conversion factor. But instead of just coming right out and give us conversion factors, you're given this table. So I'm going to come up with a shortened version of it. So we've got like one column would be like dollars per foreign, the other column would be like foreign per dollar, and they use the word foreign so that it can apply to all of these different rows. So it could apply to pesos on that row, foreign could be applied to yen on that row. And you aren't given both of these columns so that you'll have the numerator and the denominator. That's a common mistake I see, is people try to use both columns' values. We just need one column's value, but this way you like always have the ability to write it with the number in the numerator and not necessarily have to use a number in the denominator. And so I'm going to use A just as a random number. If you have an A here on the pesos line in the column dollars per foreign, what that means is that there is A dollars per 1 peso. So you're going to see a little bit decimal here. That's how many dollars is 1 peso. And so if you need to change to dollars, this is a great thing to use. I could put $8 over 1 peso, multiply, pesos would be gone, and I'd have dollars. If instead you started with like a foreign value, if you started with like a dollar value, and say you wanted to go to yen, we would want to use something like this, because this value right here, this B, because it's on the yen row and in the foreign per dollar category, is telling us that B foreign value, so B yen, is $1. So I can multiply the dollars I had by that ratio, B yen over $1, and end up with the number of yen I want. So if you'll notice, these numbers from the columns are actually what starts that ratio, and then it's a true unit ratio. It's per 1 of the second value that's listed. We're going to try a few of these now from our test review. So we've mentioned here like how to work numbers 2 and 3, I think. So let's work a few of the other ones. We'll work 5, and let's do 6 and 9. So starting with number 5, it says you've rented an apartment in New York. It's 40 by 15 feet and has 9-foot high ceilings. Let's find the area of that. So we're thinking about like how far is it around. It's 40 feet long. It's 15 feet wide. We multiply those to get area. That gives us 600 feet squared. And units will be important, and so that makes sense that we get squared feet. Then we're going to find area. So we're going to take, we're going to find volume. So we're going to take that area, is what I was thinking in my head, and multiply it by height. Or you could do 40 times 15 times 9. So let's multiply those, and we get 5,400 cubic feet. So whether you did 40 times 15 times 9, or you took that 600 we already had times 9, this is what we've got. And so we go to answer C, and it says if your heater heats 5,000 cubic feet at the most, usually less, will it work for your apartment? And you know, we have more than that, and so that's not good on heaters to have to overwork. We have 400 more than the max, 400 cubic feet more space for them. So not a good plan. Sorry. Jumping down to number 6, we're trying to convert we've got 6,500. We've got 6,500 centimeters. And we want to change that, so I'm going to use conversions. I'm going to multiply by fractions. I know in that first fraction I want centimeters at the bottom so that I won't have centimeters anymore. And my goal is to get to feet, and if you'll look through our conversion factors here, we don't have anything from centimeters to feet, but we do have a centimeters to inches. So to fill that in, it says 1 centimeter is approximately 0.3937 inches. And so where would that leave me? That would leave me at inches. So I went ahead and wrote times, and I'm going to put at least one more fraction in there because I'm not at feet. I know in this next fraction I want inches at the bottom again, so that those can cancel. My final goal is feet, and I do know how those two are related. So I need to figure out, the minute I write feet and inches, I start thinking about 1 and 12, but I have to think about, do I mean 1 foot is 12 inches, or 1 inch is 12 feet? And we mean that first one, right? 1 foot is 12 inches. And then we can multiply 6,500 times this fraction, or times 0.3937 divided by 12. Kind of a shorter way to get that typed in. And either way, we get 213 point, and if, you know, there is a 2 there if you type this in your calculator, but we do need to round it up because of the value after the 2 to a 3. And you'll notice the inches are gone, so this is in feet like it was we wanted. And then number 9, practice a good conversions. For money, we start out with 8 euros, right? Always start with what we've given, times, and then some kind of conversion factor to help us change. And I'm going to go ahead and write euros in the bottom, and the goal is to go to dollars, and I have the ability to jump straight from euros to dollars. That's one of my columns. So I need to find the column that says dollars, and then the per, and then euros. So dollars per foreign, and then down to the euro line, and I get the number 1.32. That does go here in front of dollars. $1.32 is 1 euro. I don't always put the number in front of dollars, like wherever I get it, but if it's in that column, dollars per foreign, it's the number of dollars per one foreign item. The other column is the number of foreign, so yens, pounds, dollars, whatever, Canadian dollars, whatever, per US dollar. So I'm going to multiply these, and if I'm rounding to the 10th, technically this is 1060. If I want to round to cents, it's 1056. Either way, we now have our answer in dollars.